So I promised I'd make a video on how to solve exam chapter 3. And so let's get to it. So these are all the rules. So the first question here is asking us to find the linearization. So that means that we need to know the point and the slope and find the tangent line. And so how you find the slope here, that's raised to the 1/3, 1/3 x to the negative 2/3, and we're evaluating at x equals 8. And you can put that in your calculator if you like to figure out what that is. So you can also do it with your head if you like. It actually turns out nice. So this is 8 and then raised to the negative 2/3. 1/12. So that's the slope. Then the point, so we needed the slope and the point is an ordered pair with 8 in for x. When you put to find the y, the cube root of 8 is 2, so there's our point. So our tangent line, which that's what the linearization is the tangent line, is y minus 2, y minus y1 equals the slope, 1/12, times x minus 8. So this becomes 8 over 12 is 2/3. So this is 1 over 12 x minus 2/3. Then I'm going to add 2 to both sides. So y equals 1 over 12 x, and then I had negative 2/3 plus 2 is 4/3 plus 4/3. And then this is my linearization, so I'm going to put that right here, 1 over 12 x plus 4/3. Yeah, you can use there's a formula that they have in your book. It's all it is the tangent line. I don't like to have more formulas running around than I need. Asked me to find the critical numbers for f on the interval negative 2 to 1. So I have to find the derivative. That's where the critical numbers, that's where you can find them. So this is negative 12 x to the second plus 3. You want to know when that first derivative is equal to 0. And I'm going to factor out a 3 here as I write this down. So this would, and in fact I'm going to factor out a negative 3. So this is going to be 4x squared. I'm not going to factor that. Why am I doing that? I decided not to factor it. So this, I'm going to separate it is what I'm going to do. That would be better. And so I think it would have factored though, but I don't know why I was going to do that. So I almost lost a negative there in my chit chat. And so I'm going to get x squared equals negative 3 over negative 12, which is 1/4, right? Is that okay? Negative 3 over negative 12 is 1/4. So my critical numbers are, when I take the square root here, right, x equals plus or minus the square root of 1/4, which is 1/2 plus or minus. And that's in this, both of these points are within that interval. So far I have for critical numbers positive 1/2 and also x is negative 1/2. And then the other thing you want to know is where your first derivative is undefined. And on this particular one, the first derivative is not undefined. So I'm just going to make sure you know that I thought about it. Okay, I said using calculus because I didn't really want people to graph it or anything like that. I wanted them to use the calculus method of finding the absolute max. So how you find the absolute max is you test. The calculus method is to test the critical numbers, CN critical numbers, and the endpoints, right? So I'm going to be testing those in F. So f of half, f of negative half, there's my critical numbers, f of negative 2, and f of 1. And I'm going to be putting those into f. And the highest one is the absolute max. So negative 4 times, and I'm putting in half, so 1 divided by 2 raised to the third, and plus 3, and then I'm putting in half, 1 divided by 2. And I just thought I would let my calculator do the work for me. That's 1. And I'm going to come back here and I'm going to just stick in a negative because negative half is the other point. And I could have used the fraction key on my calculator. I chose to use the division. That's negative 1. Now I want to try negative 2. So I think I can come in here and delete those two things and get negative 2. So I get 26. That's way big compared to these other two, right? And then 1. So I'm going to delete out that and put in 1. And I think that's going to be smaller as well, but I'll go ahead and give it a try. So my absolute max is f of negative 2 equals 26. Because it's the biggest number there. Okay. Then the third question says using calculus, because again, they didn't want you to graph it and go by the graph of it. Find the inflection points and the concavity on what concavity, concave up or concave down on the interval. And they said 0 to pi over 2. So I have to take the second derivative to find those kind of things. So this is 2x, and I need the chain rule here. So this is going to be 2 times the cosine of 2x, right? And then the second derivative, this is going to be 2, and then this is going to be plus, and then I'm going to need the chain rule. Whoops, I'm going to need minus there, aren't I? Because the derivative of cosine is negative sign. So I'm going to have a 2 from the chain rule come here. So this is going to be negative 4 sine of 2x. Okay, and we're going to be setting that equal to 0 and asking ourselves when it's undefined. It's not ever undefined, and so we don't have to worry about that. Should have had one where it was undefined. I'll remember that for the final. And so perhaps. And so no promises, right? So I'm having this, and how you solve something, you got sine in it, you want to get sine all by itself. So I'm going to take away 2 from both sides, and I'm going to divide by negative 4. And when I do, I'm going to have over here negative 2 divided by negative 4, which is half. And so I'm like, oh, wait, that's a friend, right? I think I know the sine of what angle is half. And if you don't know the sine of what angle is half, you need to get where you do know that. And that's pi over 6, right? And so my angle is pi, 2x is my angle, is pi over 6. That's the angle in the first quadrant, plus 2 pi k. I'm going to put it like that. And there's another angle that also gives half. There's 2 of them. And so there's one in the first quadrant. It's right here, pi over 6. And then there's one, because all students take calculus, there's one that's in the second quadrant where the sign is also positive, and it's that angle right there. And that angle is 2 pi minus pi over 6, which, oh no, not 2 pi, pi minus pi over 6, which is 5 pi over 6, plus 2 pi k. Right? And then we have that our angle is 2x. 2x equals, and then there's more than one way of going it, and this is a way that I've recently learned, and I kind of like it, because 2x equals, I mean, it's really good for this one anyway. You guys can see if you like it. I'm going to divide here by 2. I'm going to divide here by 2. Remember, k is any integer. And so when I do that, I get x equals pi over 12 plus pi k. And then I'm going to get, you know, depending on my values for k, right? If k is 0, then I get, for my answer, I get x equals pi over 12. And if k is 1, then for my answer, I get pi over 12 plus 1 pi, right? So 1 over 12 plus 1 is 13 pi over 12. And you can see that for my interval, I'm too big, right? 13 pi over 12, this is too big for my interval. So there's no reason to go this way, right? And if I do negative, k equals -1, then I would be subtracting, and so that would be 1/12 subtract 1. I put subtract 11 in my calculator, and that's a -11 pi over 12, and that's before my interval, right? So that's not right. Okay, so we have one critical value there, and now we're going to see about critical values over here. Remember, our angle was 2x, 5 pi over 6 plus 2 pi k, where k is any integer. I'm going to divide by 2, divide by 2, divide by 2. So I get x equals 5 pi over 12 plus pi k. If k is 0, then I have I have x equals 5 pi over 12. If k is 1, so let's see if it gets too big. So I had 5 divided by 12 plus 1 is 17. That gives me x equals 17 pi over 12, and that's bigger than 1. That's bigger than pi over 2. Uh-oh, is this bigger than pi over 2? No, 6 pi over 12, right, is pi over 2. So this is smaller than that. That's smaller than that. And I think if I come over here and do a negative, we can try it, but I don't think it's going to yield anything. Let's give it a try. So I'm going to take 5 twelfths, and I'm going to subtract 1. Subtracting 11 again. Donna. X equals -7 over 12 pi, and that's negative. So these are my two critical values, and I'm going to put those on my number line. Did I already say that it was never undefined? I did. Okay, good. I'm going to put these on my number line. So here's 0, here's pi over 2, and here's pi over 12, and here's 5 pi over 12, and there's no scale to this. And you can have scale if you want. I decided not to. I'm going to test in the second derivative. I'm going to write that here. I wouldn't probably, but just so that everyone knows, I'm going to be testing in the second derivative. I can't spell derivative. I'm going to put D-E-R. I'm going to pretend like I didn't get myself stuck. And so testing in my second derivative. Now this is 3 divided by 12, right? Pi divided by 12 is 0.26. I was about to say 0.25. And so I'm going to try something like 0.1 so that I make sure that I'm in that region right there. And I'm going to put this in my second derivative. So my calculator's in radians. 2 minus 4 sine of 2 times, and then I'm going to put in 0.1 for in that region. And all I care is it positive or is it negative? And it is positive. Okay, and then so over here is positive. And then I'm going to want to try something in between. So remember, this was around 0.26, and I'm going to get another calculator if I have one here, just because I don't want to have to clear that out there. And my estimating right now, because I'm tired, I made like 7 videos today, is so 1.3. So I'm going to try 1 is what I'm going to try. So I'm going to try the second derivative at 1. And so all I have to do is take out the decimal point on that calculation, and I get negative. And all I care about is the sign. So this is negative. And then I want to guess something near pi over 2, right, in between there. And so pi over 2 is 1.57. So I'm going to try 1.5 just because I don't remember what this other value was. But 1.5 will be good because it'll be right here close. And this is positive. And so in the second derivative, I tried 1.5 and I got positive here. And now I'm ready to answer the question. So they asked me what was my second derivative, and it was 2 minus 4 times the sine of 2x. And then they asked me when was it concave up? And it was concave up from 0 to pi over 12, and also concave up from 5 pi over 12 to pi over 2. And then when was it concave down? Well, it was concave down from pi over 12 to 5 pi over 12. And what are the inflection points? This is an inflection point, and so is that. So at f of pi over 12 is an inflection point. And I remember that you're going to be plugging that in to here is what you are. But they said that I could go ahead and use the y value to be rounded to the 10th. So I'm going to be putting in right here, and so pi over 12, remember, so pi divided by 12 raised to the second, and then plus sine, and 2 times, and then pi divided by 12. And so I know that you could have come up with what that is, but I just want to put it in. And I'm getting 0.56, and they said rounded to the 10th, so that's 0.6 rounded to the 10th. And then my other value, so I wrote it there, and then my other inflection value was f at 5 pi over 12. So all I have to do is come in here where I put pi there and put a 5 before it, right? 5 pi over 12, 5, and that's at 2.2, right? So, and they said to the 10th, so 2.2. It's an ordered pair. Now, I'm not caring if you write it, I told you guys, in function notation, and so some of you might be giving it to me in ordered pair notation like this, and I'm okay with that too. I'm fine. To me, this is an ordered pair as well. I don't know. It's function notation for an ordered pair, but either one is good. Okay, we did a lovely job on those. Then here they asked me to find the slant asymptote, or the vertical asymptote, or the horizontal asymptote. And so I can kind of tell that this will not, this is not going to factor and have an x minus 2. So that tells me that there is a vertical asymptote. It's at x equals 2, where the denominator is 0. There is not a horizontal asymptote because the limit of my function here, as x goes to infinity or negative infinity, of this function, 3x squared plus 5x minus 1 over x minus 2, dominant term analysis is these, right, with those being ignored, gives me the DTA, right, gives me that this thing is going to 3x, which is going to infinity. So that means that there's not a horizontal asymptote, which means when you long divide, you'll find the slant asymptote. So I'll long divide and find the slant asymptote. So dividing the liters, 3x squared divided by x is 3x. Multiplying, I get 3x squared minus 6x. So multiplying. Then I'm going to subtract, so distribute the negative, right? And so here times here is 0. Here times here is a positive, and when you add them, you get 11x minus 1. And so you could rewrite that if you liked, but I'm like, it's too messy, I guess, to write. So this is going to be, when you divide these liters, plus 11. And then that's what I need to know is this, right? That's the slant asymptote. So y equals 3x plus 11. So here, the vertical asymptote, well, I can see that this thing isn't going to reduce, because if it reduces, that's not a vertical asymptote, right? So there's two vertical asymptotes, x equals negative 2, and also x equals positive 2. And then the horizontal asymptote happens at the limit as x goes to infinity, also negative infinity, of 5x over x squared minus 4. Which is dominant term analysis, right? is 5x over x squared is, where did my limit sign go, right, is the limit as 5 over x as x goes to infinity, which is going to 0. And so, and it wouldn't have mattered if I had said plus or minus infinity, so I probably should have said plus or minus infinity, still going to 0. So even here, if this is plus or minus, still going to 0. So that is my horizontal asymptote. There's only one, and that's at y equals 0. And that means there's not a slant asymptote. So you have one or the other. So, okay, so we did that. Then to find this limit by dominant term analysis, these are the leaders. You can only do dominant term analysis if you're going to infinity. So I have the limit as x goes to infinity. So this is DTA, dominant term analysis, of 4x squared divided by 6x squared, which is 4 over 6, which is 2/3. And then the limit as x goes to negative infinity, and I like it better to write this as 2 over x to the 4th, and that's just me. And as this gets, negative infinity raised to the 4th, this is getting really, really big, big, right? Because raised to the 4th makes it positive, and 2 divided by a really big number is 0. That's actually a theorem that they have for you. Okay. Because I'm going to, infinity, I'm looking at this and I'm wondering about the dominant term analysis. And the deal is that if I ignore the 17x, then you're approximating. And so, and the square root of 16x squared is equal to the absolute value of 4x, which is either equal to 4x or negative 4x. It's 4x if you're larger than or equal to 0, and it's negative 4x if you're less than 0. And since I'm going to infinity, it's positive 4x. And that's a problem because you can't get 0. So I don't want to approximate and then say this is 0. So because this is not really 4x, this is really close to 4x, but not quite 4x. And so it's okay for me to take two things that are similar in size and add them together and say that I get something bigger. But it's not okay for me to take two things that are only similar in size and say that when I subtract them, I get 0. So I'm not quite getting 0. So what you have to do about this situation is you have to multiply, they show us the trick in the book, right, by the conjugate. So then you change it from 4x minus 4x to 4x plus 4x, which is okay to do. So anyway, so that's the story there. So you multiply, you write this over 1, and you multiply by the conjugate. Top and bottom. My brother just texted me that he's barbecuing, and basically, I don't know if it was I'm barbecuing, you can come over and have some, or I'm barbecuing, aren't you jealous? But I'm going to take it as you can come over and have some because my brother is the most wonderful person in the world. So I'm sure that that's what he is on about. And he's a sweetie. And so, anyway, so I have to get done with these problems, I guess is what the story is. And I'm thinking, I wonder if he's going to have barbecue. What else is he going to have? I got to stop talking about food and get going on my problems. Now it's okay for me to subtract these because this is exactly 16x squared. I have not done any approximating yet, right? So it's when you approximate that you can't subtract things and say that it's 0. But this is exactly 16x squared minus 16x squared. And now this is when I'm thinking of approximating. I'm going to say that by dominant term analysis, that this is the square root of 16x squared, which is the absolute value of 4x, which is when you're going to infinity 4x. So in my denominator, my numerator, I have 17x, and in my denominator, I'm going to approximate this to be 4x plus 4x. So by dominant term analysis, the 17x is not that big of a deal, right? It is actually a kind of a big deal when you're subtracting them, though. And so this is 17, right? 17x over 8x. I couldn't say that. I was so excited about the possibility of whether or not I could bring my marshmallows and add to his barbecue some s'mores. And so this is 17 over 8, right? And so it's not quite 0 when you subtract it, right? It's not a very big number. 17 over 8 is not huge. It's not small. You know, if I had that kind of money in my checking account, I'd be happy, you know, $2.13 or so. Okay, so anyway, so that's my answer for that one. Is there a place for me to write it on the answer line? There is, 17 over 8. So I'm going to do that. Okay, this is problem 6. It's asking me to use Newton's method to approximate the x-intercept of the graph of the equation. Now, how you find the x-intercept is you let y equal 0. So when I let y equal 0, I'm going to have 3x minus 1 over 2x plus 1 equals 0. And that's set up for Newton's method, right? Because you want 0 on one side. And when you have 0 on one side, you call that, this, for Newton's method, you call that f of x. So our f of x is equal to 3x minus 1 over 2x plus 1. And then I want to know the derivative, because Newton's method has the derivative in it, right? It's a formula. And focus, my friend, focus. So 3x minus 1, I have to use the quotient rule. I told you guys when we were going over what could be on the test that I kind of thought that I needed to have chain rule, quotient rule, and product rule. And I'm not sure, did I make it? Did I get all of them? So let's see here. 3 times this, and minus, and then this times this, all divided by this squared. And in the numerator, I can see some joy happening. 3x times 2x is the same as 2x times 3x, right? 6x, both of them, and they're subtracting. So I'm going to be careful here. So this is 6x plus 3 minus 6x plus 2. So I'm going to have 5 in my numerator, 2x plus 1 squared. So this is 5 in my numerator. And then I'm going to set my calculator up, right? They said the initial guess was, what they say it was, 1. Okay, and I'm going to set my calculator up. I'm going to put 1 in so that it's in the answer. And then remember the next guess is equal to your last guess, x1 minus f at x1 divided by f prime at x1, right? And then that'll change as you kind of go along. So I got 1 in there. And then what I'm going to do is I'm going to put this answer is what I'm going to put. So down at the bottom I have answer minus, and then I want the fraction, and then I want a fraction because f is a fraction. Remember, f is a fraction. It was 3x minus 1. So 3 answer minus 1. And in the denominator, 2 answer plus 1. And then going downstairs, so now I'm down here, and I'm looking at what f prime is, and it's this. So I want a fraction, and I want 5 in the numerator, and I want parentheses 2 times the answer plus 1 quantity squared. Okay, when I hit the equals one time, this is my x2. And when I hit it another time, that is my x3. And I told you, do not round at intermediate steps, which we didn't, and give the exact answer either as a decimal or a fraction. So I have them right now as fractions, and so that's great. And so I'm going to leave them as fractions. You could put them as decimals if you wanted. So this is exactly equal, 1 divided by 5 is exactly equal to negative 0.2. And this is exactly 1 divided by 1.25 is equal to negative and then 0.008. And there's somebody at my door. Okay, a rectangular chicken pen will be bounded on one side by an existing chicken coop. The other three sides will be fenced. So this is kind of like the problem that we had where they had a barn. Instead, they have a chicken coop, and they're going to fence three sides. So here is my coop. Here is my pen, fencing three sides. The guidebook recommends an area of 50 square feet for 8 chickens. So we're given that the area is going to be 50 square feet. What are the dimensions of the pen that will minimize the length of fencing needed? Okay, so I'm going to call this X, and I'm going to call this X. I'm going to call that Y. You can name it whatever you want. It doesn't matter. And we know that the length of fencing, which I'm thinking about calling L, but I could call F if you wanted, whatever, it doesn't matter, is 2X plus Y. Okay, and this is what I would like to minimize. And the problem is that I have two variables over here, but no worries, right? I know that X times Y equals 50 because the area, right? And so I'm going to, you solve for Y or you can solve for X, it doesn't matter. So I'm going to say that Y equals 50 over X. My choice on that, which is 50 X to the negative 1, my choice again on how I write that. So L equals 2X, and then I'm going to replace in here for Y 50 X to the negative 1. And then now I'm ready to find the derivative, right? So now, next, I'm going to find L prime, right? So L prime equals 2 plus, it's really going to be minus though, 50 X to the negative 2. And I want to know when L prime is 0 and when L prime is undefined. So 2 minus 50, I'm going to write this over X squared, equals 0. And your choice on how you solve that. You could multiply by X squared. You could get that over there and cross multiply. I think that I kind of am a kind of person that likes to cross multiply, so I think I'll do that. So this is 2X squared. It comes out the same, of course. And so people always tell me, no matter which way you choose, that whatever they thought to do is better. And so, yeah, it's good, right? So plus or minus 5. Doesn't make sense to have the side of a chicken coop be negative 5. So our critical value really there is 5. And it is undefined at X is 0, but that doesn't make a pin. And so no pin. So we know that that cannot be it. And so we only have one critical value. And in order to find the absolute max, you should think about the critical values and the endpoints, right? And because that's really what I want. Oh, excuse me, it was absolute min. I want the absolute min, and I should be looking at the critical numbers and the endpoints. But on these pin problems, the endpoints don't make sense because that would be having X be all, would X being all of the fencing here and no fencing on Y, or that would be an endpoint, or no fencing on X and all the fencing on Y. So no pin would be made. So there's really isn't endpoints on this kind of thing. And so it's just the critical points, which we only have one of. And so we want to know what Y is, and we know that Y equals 50 over 5, 50 over X, which is 10. So the dimensions of the pin are 5 feet by 10 feet. And it said use units, and I have used the units. Now they want me to verify that I found a minimum, and you can do it using the first derivative test or the second derivative test. I'm going to use the second derivative test because that's how I roll, and that's what I want to do. So the second derivative here, that's the derivative of this is 0, and this would be positive 100 x to the negative third, which means the second derivative is equal to 100 over x to the third. Remember what x was? X was 5, so this is 100 over 5 to the third, and all I care about is whether this is positive or negative, and it's positive. So since it's positive, that means that at my critical number, right, it's concave up. So at the critical number, so here's the critical number, we know that it's concave up. So the critical number is a turning point, right? And if it's concave up at that turning point, then it is it's a min, right? And so, awesome. And you're not doing a formal proof. It's just I'm going to say concave up. It's just a verify. Okay, so we did a good job on that. One last problem, my friends. And I said that I was trying to have chain rule, product rule, quotient rule, all of them. It's very important. And so here's product rule, right? And probably this is the find the derivative of everything test, right? So it says this function satisfies the three hypotheses of Rolle's theorem on the interval -1 to 1. No need to verify. Find all numbers C that satisfy the conclusion of Rolle's theorem. Sketch the secant line and the tangent line on the graph below. So we're gonna do that. So the conclusion of Rolle's theorem, the then of Rolle's theorem, is that f prime at C equals 0. So I need to find the derivative. And so wherever you want to find your derivative at, it's a product rule. So u equals x, and v equals the square root of 1 minus x squared. U prime equals 1, and v prime equals, so I have to use chain rule. So the derivative of the outside is 1/2 the square root of 1 minus x squared times the derivative of the inside, and the derivative of 1 is 0, and the derivative of this is -2x. So when the dust clears, the 2's cancel. Goink, goink. I feel like I need parentheses there so that I don't start thinking that's a subtraction. So -x is what I have. And so let's see here, the derivative, I'm going to write it here. It was product rule, right? So it's this times this, so that's -x squared over the square root of 1 minus x squared, right? X times x, and it was negative, and then plus, and then the square root of 1 minus x squared. And they're saying f prime at C, so they're saying change all these to C's, and okay, I'm in, if that's what they want to do. And I told you guys that I couldn't really get in a bunch over that. Oh, I put C, I put X and I meant C. You got to change them all. So I'm going to have, I'm thinking about hopping this over here and cross multiplying. I'm kind of about cross multiplying tonight. And so this is going to be C squared over, and this is over 1, right? And over this, 1 minus C squared. And that works pretty good, because when you multiply these together, you get the square root times the square root, which is 1 minus C squared, right? And then over here, I get equals C squared. So I think I'll add the C squared to the other side, so it doesn't turn out to be that hard of a, or that bad of a solve. But 1 equals 2C squared, so half equals C squared. And so C equals plus or minus the square root of half. And the square root of half, right, square root of half, you could do it on your calculator. You can also do it with your head. It doesn't matter. But is square root of 2 over 2. And I want to make sure, that 2 is not very neat. I want to make sure that both of these are in my interval. And so this is around 0.707, so plus or minus 0.707, right? And my interval went from -1 to 1. And so this is my C value. C equals the square root of 2 over 2, also negative square root of 2 over 2. And of course you could write it with the plus or minus. I don't care about that. And I'm just going to note that C is approximately equal to plus or minus 0.7, because I really can't get too much more accurate when I'm graphing. So the secant line, remember it went from x is -1 to x is +1. So here x is -1 is, and here x is +1. And because it's Rolle's theorem, I expect that that's a horizontal line. And so if it wasn't a horizontal line, I'd be like saying, what the heck? It's supposed to be a horizontal line. So there is the secant line. So on the mean value theorem, it might be something other than a horizontal line. Then here's 0.7 right here. This is up by tenths. So this is 0.707, right? So it's just a smidgen beyond. So it's just right there. And remember, it should be, the tangent line should be a horizontal line. And so here is a tangent line. And another one here at negative 0.707. So somewhere right here. And I'll draw that in there. And so I'm trying to draw a horizontal line. And so that I had two tangent lines. And that's it.